Okay, so let's get week 3, day 1 started. And today we're going to talk about fractionation, I guess, a little bit, but really more why we're going through this whole rigmarole. So, you know, if you're able to create a struct, right? Like if you're able to create, struct circle. And inside of circle, you can have a point called the origin, and you can have a double for the radius, struct point, double xy. Like if you could do this, why go through the whole rigmarole for a class? You know, like the proper class design. I keep using air quotes around that because, you know, for some applications this would actually be fine, honestly, and people tend to over engineer things sometimes. But what's the benefit of having a constructor and a destructor sometimes, and what's the benefit of doing the ADT thing where you don't give main access to the innards of the classes? Security, it seems like it should be security, but it's not. And let me show you that's what I thought too when I was first taking this class, was that private would somehow prevent hacking, right? Well, let me just show you something. So let's see here. Circle C. Circle pointer is equal to the address of C. Let's actually move this around. Let's see, double pointer D pointer is equal to cast circle pointer to double pointer. All right, let's use the proper way. Static cast to a double pointer. Let's see, isn't not gonna like that. Static cast is not allowed. That works. Okay. So we have a pointer to a circle, and here, let's just give this guy a constructor, just a 7.1. C out D pointer. Print out the value pointed to by a D pointer. That's what that means there. And you see we get 7.1. So if you do pointer tricks, nothing that's private is actually hidden from your own program. There's no prevention of hacking or any of that stuff that private does. Private is a convenience, really, for yourself. It involves you protecting yourself against yourself. Let's put it that way. So we're doing IS50 and CSI 41 now because it's fancy. Pods is greater than ADT. So let's take the opposite stance, Muya, and let's talk about why it's not just for you, it's for other people using your classes. Yeah, but other people using your classes could do this. Like if they wanted to edit your private variables, they can do pointer tricks. And what I did here was I made a circle. Its radius defaulted to 7.1. There's a secret constructor in there. And then I created a pointer to it. A pointer is just an int, or a long int, depending on if you're on a 32 or 64-bit system. It's just an int. It's just a number. It's a memory address. It's a spot in RAM where that variable is. And then I make another pointer, and that it's just copying the memory address over, but the type is changing. The type is changing from being a pointer to a circle to a pointer to a double. And so then when I say print the value held to that address, it's like, oh, I know what that is. That's a double, and it prints it. And in fact, it's 7.1. And so by using memory tricks and things like that, you can get at private variables. This is considered very bad practice, and for good reasons. Like, you're not supposed to do this for a reason. But but you can do it. It does not help you against the hacks. Okay. So in CSci 50B, we are doing stuff with points and circles. We're doing a little bit of computational geometry right now. We're going to move on to more game developing stuff, but computational geometry involves right now we're creating holes. So we have a bunch of points on the screen, and we draw lines around all of them. The tightest possible fit of lines that will encapsulate all of the points on the screen. And this is useful for a lot of different purposes. And so that's their assignment. It's due on Friday. And so why is this bad? Okay, so let me give you a justification. Maybe not bad. Maybe bad's not the right word. But not good. Okay, so let me get rid of this garbage down here. We will never speak of it again. So, so I'll just create a little default constructor here. So why is this bad? So, if you want to tell if somebody is within the radius of a circle, right? Do you guys know how to do that? Like to, test to see if you are inside a circle. You guys know how that works? That's funny. Yeah, none of these are. Very elusive. Okay, here we go. So if you got a circle is defined by an origin and a radius, right? And you want to know if a point is within the circle. So what you do is you take the distance of the origin to the point, and if that distance is greater than the radius, in this case the radius is 6, then it's outside. So it's the Pythagorean Theorem. Do you guys all know who Pythagoras was? Do you guys know who Pythagoras was? He's famous for a Pythagorean theorem, but do you know who Pythagoras was? He's probably dead now. That is also true. He is dead now. He was actually a religious figure. So he actually ran like a religious cult, and they were like very big onto geometry and things like that. True story. So there's a whole religion based around this kind of stuff. So yeah. So basically, what you do is if you want to see if a point is within a circle, you use the Pythagorean theorem, take the distance from the origin of the circle to the point, and if it's smaller than the radius, then it's within. If it's bigger than the radius, then it's outside. If it's on the radius, then I don't know, you pick. Okay. So here's the try. Here, let's do that. Let's do that function first. Then I'm going somewhere with this. Okay. So bool is inside given another point. And because this is an object, I'm going to use it const reference, right? And so double distance. There's a Pythagorean function in the standard library called hypot. So hypot will be the other points x minus my origins x. And p dot y minus origin dot y. So this will be the distance. The point is from the origin of the circle. And I'm going to return if distance is less than or equal to radius. Okay. Still mad at me for something? Okay. So let's put the radius at I don't know, 5, and the origin at sure 0, 0 is fine. Okay. We'll have a point P. Point P is equal to, let's see, let's do one inside of it. So 3, 3 will be inside of it, I think. Okay. And then we'll see out bool alpha. Let's make it a little smaller. 3 squared plus 3 squared is 9. 18 squared root of 18. Yeah, that'll be fine. Okay. C dot is inside P. Okay, so this is a little bit of computational, very basic, stuff. So it's going to see if this point is within this circle. So the circle has an origin of 0, 0, and a radius of 5. Okay. And so g++ main.cc, run it. It is within the circle, but if we make it to like 30, then it is not within the circle. Okay. Now, the most expensive thing in this computation, and these things are used a lot, by the way, when you're doing, when you got here, you saw an extra credit assignment. There is no extra credit right now. I'm probably going to do a talk on sea shanties maybe next Friday, something like that, but there is no extra credit. Sometimes when I publish a module, it publishes all the old stuff, and then I have to go through and unpublish the old stuff. It's kind of annoying. Okay, so yeah, there's no extra credit though as of yet. So the most expensive thing here is actually the square root. So square root can actually be quite expensive. It's fairly easy to do a multiply. The squaring, the subtraction, it's pretty easy. Square root can be fairly expensive. Like a square root could cost as much as like 80 additions. Okay. And so as it turns out, you actually don't need to do the square root. You don't need to do the square root to do this is inside function. Okay. Anyone any math skills? Figure out a way of doing a comparison without a square root? What do you mean by expensive? I mean, here, let me do the full equation here. Square root of here's a full Pythagorean theorem, right? How of hypod is just the same thing as this. Right, so that and how of u. There we go. Okay. Pythagorean theorem. Okay, so this is the Pythagorean theorem. It's the same thing that hypod has, except it's showing what's actually happening a little more clearly. So does it not like square root? Why do you not like square root? Did I let's see square root of should all be one thing. That should be a plus. There. Okay. There's the Pythagorean theorem. That's the same thing as hypod. It just is a lot more typing to do it. Okay. What's the reason for a struct over a class? Well, the nice thing about a struct over a class is everything's public. It's less typing, and you can this is very easy to read. Like what is it? It's two doubles. It's an x and a y location, and so sometimes that's all. Sometimes it's really all you need when you're making a class. And I have a function that takes a point. Okay, cool. It's taking an x and a y location. Sometimes you don't need anything more complicated than that. But now I'm going to justify why we go through this rigmarole with like constructors and like private and public and all this kind of stuff. Okay. So the square root is expensive, and so they said, "What do you mean by expensive?" The square root function, and it depends on what kind of CPU you have, etc., etc. It's a complicated question to answer, but let's just say the square root function, as a rule of thumb, costs the same amount of time as 70 additions. Okay. So, for the sake of argument, let's say that a multiply and an add and a subtract are all the same cost. It's not, but it depends. It's complicated. But let's just say. So what's the total cost of this? Well, there's one subtract here. There's one multiply, because that's just doing a multiply. That's 2. There's an addition. That's 3. Subtraction, that's 4. There's a multiply, that's 5. So there's the Pythag function has 5 normal arithmetics in it and 1 square root for a total cost of 75. Okay, so 70 of it's in the square root, 5 bits in the rest. Let's see. It's not accurate, but let's see. It's good enough for our purposes right now. So Mr. Wolf says, yeah, just square both sides, right? Because if you're doing a comparison, you actually don't need to know what the actual distance is. All you need to do is compare the results. And so since square root doesn't do anything to change the relative magnitude or sign of the things, what you can actually do is this. You can say, rather than doing this whole square root nonsense, let's just delete that. And then rather than calling this distance, we'll call this distance squared. Do you guys remember the Pythagorean Theorem? Square root of a squared plus b squared equals c squared. So this is a squared plus b squared. And now we're going to compare it against c squared, the radius. Okay. And so return the distance less distance squared less than or equal to the radius times radius. Okay, so now our cost of this function has gone from 75 to 6. So it's over 10 times faster because we eliminated the square root. But every time we do this comparison, we're going to be squaring the radius, right? We're going to be squaring the radius every time. And so you might be like, you know, it'd be nice if we could just do this, right? Let's just write down double radius squared, right? Is equal to, I guess, 1 also by default. You guys see what happened down here? It broke this. It broke this. And the reason why it broke is because the people using your code, main, now need to know about every, because this isn't that really, like nobody needs to know about that, right? All anybody really needs to know about is the radius of the circle. Nobody really needs to know the radius squared because they can figure that out, I guess, themselves. But we want to keep track of that because that'll save us a multiply every time down here. You guys see that? Like if we could just always keep track of radius squared, then rather than having to do this multiply every time, which is going to raise our cost from 5 to 6, that's a 20% increase in cost, right? And that's assuming that the multiply is 1 cycle, which it's not. So this would be a really nice optimization where we can just kind of write down what the radius squared is. And now we've got to go through, we just broke all of our code, right? We just broke all of our code. Everybody who is using the circle, none of that code is going to compile now because we broke it. Do you guys see what starting to see what some of the problem is? Right, so we had all these people that were using our circle class, and then we were like, okay, let's optimize our class. Let's optimize our class and put in this radius squared guy that will make our function go 20% faster, right? Is that the fast inverse square root code from Quake? Yeah, it is. So how many cycles would that be? 1, 2, 3, 4, 5, 6 cycles or so. Yeah, there are faster ways of doing square root, and in fact, a lot of people do very inaccurate square roots. Like they'll have a table and they'll look up things in a table to like 2 digits precision or something like that. There's all sorts of optimizations. So let's not worry about that right now. So, but problem one, everyone using our code, well, the code breaks because we changed circle. Do you guys understand? Like, we had, let's say that we'd been using this circle class, the circle struct, whatever, for like 10 years. And there's millions of users of our code. And then we want to come in and we want to make this function here faster. We want to make it faster by writing down on a piece of paper what the radius squared is, because it doesn't change very often probably. And so we can just write down what the radius squared is, and then every time we do a is inside test, we just use the squared version instead of having to do that multiply every time. Are you guys following me on this? Like, this is a very common thing we do in computer science. Like, look, we don't need to recompute radius times radius every time. We can just compute it once and then just kind of save it, right? Would making a constructor fix that? Yeah. Yeah, and so we're starting to see why we do the ADT approach, because the people using the circle class don't need to know, philosophically speaking, they don't need to know what we're actually doing over here in circle. So one person's writing circle, another person's writing main. Sometimes you're the same person, right? In this case, I'm the same person. But even still, this is going to annoy me, because if I made a change here, by adding that, this code breaks down here. And if I've used it a million times in my code, I've got to go through and refactor my code a million times, and I would have to, and it's not as simple refactoring either, because I have to make sure that I set radius squared to be the square of the number, right? So I can't just like do it using a tool. I would actually have to go through and manually, one by one, set every, one of the second parameters to be the square of the first parameter, which is annoying, and I would probably mess up at some point. Then that would introduce bugs into my code. So the proper way of doing this is, there for a reason. So we would make this private, turn it into a class, and then make a public section, and then we would make a constructor, circle, circle, double, new radius equals 1, point, new origin equals 0, 0. I'm adding default constructors again. So that means if you don't specify one of these parameters, it'll default to, if you don't specify an origin, the origin will default to 0, 0. If you don't specify a radius, it'll default to 1. That way I don't have to make 3 different constructors. And I'm not going to have anything for radius squared at all. Right? Like, I don't, the user of the code doesn't need to know anything about radius squared. I can compute that myself. And so radius is equal to new radius, and origin is equal to new origin. And then I will add my little optimization here. Radius squared is equal to radius times radius. Okay. And so this is radius squared. Boom. Okay. So do you guys see that? So this constructor is a default constructor, a 1-parameter constructor, and a 2-parameter constructor, all in one. It's an all-in-one constructor. I don't understand what the new is for. Yeah, it's just, I just had to come up with a different name for it. Some people will use the same name as the parameter. They would call it radius, and then I'd have to say this points to radius equals radius. Yeah, it's not using like the new operator or anything. These are the parameters being passed to the constructor. So if you have a default constructor like this, right, circle takes no parameters, and then you could have circle with 1 parameter, double, new radius, radius equals new radius, right? So if you passed one thing to the circle down here, if you passed one thing to it, like that, right? You guys understand how you can have a constructor that takes different amounts of parameters? So, yeah, I just use the word new underscore. That has nothing to do with the new keyword. If you don't like it, you can call it radius 2. Some people, yeah, like at Fresno State, they like doing it this way. So they'll say this points to radius, this radius. It's a style thing. It's the exact same thing. So you can have a default constructor that takes no parameters. You can have one that takes one parameter. You can have one that takes two parameters. Point, origin. That's a two-parameter constructor, but the way I like to write my constructors is that I do it like this. And so what this does here is if you don't pass in a second parameter, the second parameter will default to 0, 0. And if you don't pass in a radius, the radius will default to 1. Okay. And they fill in left to right. So if you leave, you can't leave out the radius and pass in an origin. You have to, if you have the first parameter, you have to have the first parameter. You could leave out the second parameter. You can't have the second parameter and not the first. You have to do them in order. So instead of doing all three of these constructors here, I like to do this instead. Just have one constructor instead of three. Okay. This constructor here is doing the same thing as all of this code here. Makes it a lot more compact. I don't have to copy paste code. Okay. Because, like for these constructors, I forgot this code's buggy, right? Radius squared equals radius times radius. Right. So rather than all of this code, rather than all of that code, it's just that. This is called an initializer list. And this little bit highlighted here, that means in English, you see the colon? We talked about this last time, but I'm going to reiterate it. The colon means initializer list, I guess. So initialize these variables. Initialize radius with new radius. Initialize origin with new origin. So it's the exact same thing as this code here. It's just more compact. And it's better practice to write code like this. It's better practice to write code like this. If all you're doing is just setting one thing to another thing. If you got something complicated, then you got to write code like that. But yeah, that's preferable to this, even though they do the same thing. And the reason for that is because the compiler can look at this and do certain optimizations and say, okay, this depends on this, and there's certain optimizations that the optimizer can do. And also, if radius was a constant, then you could set the constant here, but you can't set it. You cannot set it that way. So you can do more with an initializer list. What if the constructor takes multiple types of the same type in a row? They fill in from left to right. So if you took in 3 integers, and here, I'll int Bob, int a void Bob, int a equals 1, and b equals 42, and c equals negative 93. C out a, b, c. Okay. So let's go over default parameters, I guess, and we'll get back to justifying ADTs in just a little bit. So if I call Bob like this, here, forget about all the class stuff for now. Let's just go over default, because I guess some of you guys didn't study that in 40. So this is a function named Bob. Bob can take no parameters. Bob can take 1 parameter. Bob can take 2 parameters, and Bob can take 3 parameters. So there's 4 different ways of calling the same function Bob. If you pass in no parameters, then A will be set to 1, B will be set to 42, C will be set to negative 93. Okay? If you pass in 1 parameter to Bob, this is what your question was. How do you know which one it is? Is the 100 going to go in for A, Is it going to go in for B? Is it going to go in for C? And the answer is they fill in from left to right. So that 100 goes in for A. Okay. So A is going to be set to be 100. So if you call Bob with no parameters, it prints out 14293. If you pass in 100, just as one parameter, you see A gets set to be 100. And likewise, if I pass in 2 parameters, and 3 parameters, you see with no parameters passed in, it prints out the default values. With 1 parameter passed in, A gets set to be 100, B defaults to 42, C defaults to 93. If you pass in 2 parameters, and if you pass in 3 parameters. You guys understand? Would it fill in from right to left on a Japanese server? That's funny. Yeah, C++ is in English. So, got some cultural hegemony going on. For all constructors, should one have destructors too? No, definitely not. Definitely not. In fact, most of the code that I write these days doesn't have destructors. Okay. The only time you must have a destructor is if you're allocating something in a constructor. And that's usually memory. So like if your constructor has a new in it, then your destructor must have a delete. If your constructor opens a socket, your destructor should close the socket. If the constructor opens a file, the destructor should close the file. You guys understand? So if your constructor like allocates something, like it's permanently opening a file, and then your destructor needs to undo it. Most of the time, though, yeah, there's something called the rule of 0, which is really important. Rule of 0. Don't do memory stuff there. Right. Yeah. No news is good news if you can avoid it. If you follow the rule of 0, you don't need to do anything really. The default stuff will just work for you. Do other countries code in English? Yeah. My dad told a story of one of his fellow programmers who was walking around in Tokyo. And my dad wasn't a programmer, he was a manager of programmers, which is why my dad kind of hates programmers, I think. Or at least thinks that they're all up to no good. Because he was a manager of them. But anyhow, one of his programmers was walking around in Tokyo and at a conference, a programming conference. And he saw one of his fellow conference attendees. He was like, hey, pardon me, how do I get to, I don't know where he's going, hotel or something. And the guy's like, sorry, I don't speak English. And so he rephrased the question, and it was probably Fortran back then, or COBOL, maybe COBOL. And so he basically rephrased this question of like, search for hoteru, and the guy's like, oh yeah. And so the guy gives him a answer in COBOL because they both spoke COBOL, which is in English, right? And so he was able to get directions because basically every major programming language is in English. English is the lingua franca. English is the lingua franca of the programming world. Okay, so when you pass 100 into Bob, is it passing 100 into A? Yes, exactly. So A is 100, B and C are left as defaults. Okay. And for this one, it fills in left to right. So if you pass in 2 parameters, the first parameter gets the first one, second parameter gets the second one. So A is 100, B is 200, C is left as default. And so it's a very nice way of just not having to write redundant code. And so this constructor here is, to come back to my point, rather than having to write all of this code and having redundant, reduplicated code over and over again, by putting in default parameters like that, if you don't specify one of them, then it'll default for you. And so you don't have to copy and paste the code over and over again. And again, this is an initializer list. This code here, colon, starts the initializer list. Says set radius equal to new radius, set origin equal to new origin. It's literally the same thing as that. Okay. They don't have like 3 alphabets, 4 technically, right? They have kanji, hiragana, katakana, and romanji. And the romanji is oftentimes, you'd think it'd be English, but it's oftentimes not. It's English adjacent a lot of times. A concept of hair. That was a hair salon place near my hotel in Tokyo. A concept of hair. Yeah. Is there a way to tell the constructor to default A but put in B? No. The default parameters fill in left to right. That's the rule. So you can't. So when you make your function, you might have to think about what order you put them in. Because it, like in the standard library, the least important parameter for like making a vector is the allocator you choose for it. And you're like, wait, what? I've never set an allocator when making a vector. And the answer is yes, exactly. You've never set an allocator when making a vector, probably. The reason for that is because the allocator is the final parameter, and we usually ignore it, and then it uses the default one. And so whatever is the least important goes last. And that's something to think about. Like if you know B but you don't know A, then you put the parameters in a different order or make a different function. Okay. So you're saying you could put an allocator in if you wanted to. Yeah, sure. Go for it. Knock yourself out. Okay, so here we've got, coming back to our point, the whole reason why we're doing this is because we want to have a class invariant. A class invariant is a rule, class invariant. It is a rule that is always true in this class. What was the class invariant for your fraction class? For your fraction class, there's a rule that must always be true that you had to enforce. What was the class invariant for fractions and fractionation? Yeah, fractions had to be positive. Numerator and denominator both had to be positive integers or 64s. Okay, so in this case, our invariant is radius squared must be always set to be radius times radius. Okay. If we did this as a struct, it would be possible for main to set these two guys separately. Do you guys see that? So like if this was, what we were doing before with the pods, plain old data structures, plain old data, have no way of enforcing this rule. Okay? So if I made a circle, I don't need Bob anymore. If I made a circle, I could just say circle dot radius squared is equal to negative 93. Why is that a problem? Why is it a problem? I've just created a circle with a radius of 5.1. Let's just make it a radius of 5 to make it easy. So radius squared will be secretly set to be 25. Why is it a problem that main could change it to be 93? Okay. Radius can't be negative. Yeah, well, the radius squared can't be negative. The radius, I guess, arguably should not be negative either, right? Or, see, somebody's probably not going to do that. But what if they did this? This is even bigger problem. This is something that new computer science students love to do. I'm going to make a circle with a radius of 5, and then I'm going to change the radius to 9. What did I just break? What did I just break? What class invariant did I just break? What didn't you break? What just happened here? If you do it the plain old data way, this is valid code, right? Because everything's public, right? So I can just set its radius to be 9. No problem, right? Big problem. It's a really big problem. Because I have a class invariant, right? The class invariant is that The radius squared must always be equal to radius squared. I changed the radius, but I did not change the radius squared. And this is probably what my code would look like if I was doing pods and a million, I have a million lines of code in a million places where radius is changing, and I have no way of guaranteeing that radius squared is going to be set properly every time that radius gets set. There's no way of guaranteeing that. And so what I do is I make this to be private, and I make a getter and setter, right? So I'm going to have one function to get and set the radius, and I can do one for the origin too, but I'm not going to worry about that right now. So double get radius, return radius, void set radius, radius is equal to new radius. Okay. This would be a standard setter. However, we have a rule. And the rule is radius squared must always be set to radius times radius, right? Oops. Maintain class invariant. You guys see that? So, it's Python, you can't have privates, yeah. Well, so this is nice now. And so what's really nice about this is that every time the radius changes, either through the constructor, it gets set originally, or somebody calls set radius, it will automatically update radius squared for us. And now we can make use of this optimization here. We can actually get a nice 20% speed increase for doing this isInside function. And this isInside function might get called millions of times a second, right? In the IS50B class, we're doing computational geometry, and we do things called bounding spheres and bounding boxes and things like that do tests, very fast tests to see if something is touching something else. In video games, it's very common for you to see, are two things touching, right? You shoot a bullet, did it, hit the target or not? It's very common. And so anything that you can do to make these things faster is good. And so with this, we were able to drop the cost of it from 75 down to 5, right? So we got a very nice speed up. And what was that, 13 times speed up? 10, 15, yeah, something like that. No, 15 times speed up. And then originally we were just going to do the radius squared calculation every time, but then we're able to pull that out and only do that when radius changes. So when radius changes, we do the squaring, and then the rest of the time we just look it up. It's going to eat up a little bit more memory, but who cares? 8 bytes of memory is, whatever. You guys understand? Do you guys see the justification for doing the ADT method a little bit more now? Because before it was all very like, you're just wasting time, man. Like you gotta get, you gotta set, you gotta get, you gotta set, you gotta get, you gotta set, and they all do the same thing, and it's just more typing, and it's just a waste of time, and this is why. This is why. If you have a rule that must always be true for your class, you can't guarantee that main will respect it. Okay? Now main cannot change the radius directly. If main wants to change the radius down here, I think with more practice it'll help be clear. Well, good news, you're going to get more practice doing this. So now if main wants to change the radius, we're going to call set radius and change the radius to be 9. Okay. And this will secretly change radius squared to the medial. You see that? I can't just do dot radius anymore. This is proper class design. Classes establish restrictions on main. Okay. Or anybody outside of the classes. I say in main, but really a class, when things are private, it's establishing a boundary. It's establishing an interface. I've got my private stuff over here, like radius squared that nobody else needs to know about. Like nobody needs to know I'm doing this optimization, right? This is on my side of the boundary. On your side, all you know is that I've got a radius and I've got an origin, right? And you can call functions to get those and set them. And you can see if a point's within a circle and all that stuff. Secretly, though, I could be doing all sorts of interesting optimizations and things like that, like this, where I'm saving the results of a computation, so that I don't need to constantly rerun it. And so by presenting an interface, let's say that I didn't do this originally. Watch this. Let's say that I didn't do that radius squared thing originally. None of the code using it changes, right? Like just like imagine I commented out all those lines. Let's say I'm going to take it out, for whatever reason. See, I just changed my code behind the boundary. I just got rid of this thing, commented out all references to it. Maybe for whatever reason I'm running out of memory, and so I'm gonna squeeze the memory instead. I'm gonna have a longer runtime but less RAM. That's a trade-off, right? Like maybe I'm making billions of these things, and the extra, 8 gigs of RAM it's taking up is, pushing me over limit. So I'm just gonna be like, what? I'll take the 20% speed penalty. I'll take the 20% speed penalty in exchange for saving 8 gigs of RAM. Maybe I'd do that. I don't know. But do you guys see what happened here? All this code still compiles. There's an interface. And so main uses the interface, and behind the interface, I can change it however I want. This is why we do this. Because without this interface, without this separation of concerns is what it's called, main needs to know everything that circle's doing, and circle needs to know everything main's doing. And if you change something in one place, it has to change in every other place that uses it. And maintenance of your code becomes a nightmare, right? Like when I first put in this thing here, it broke the code down here because I was using it as a plain old data, and I have to fix a million different instances of my code. Instead with a getter and a setter and a constructor, with this interface, I can change my private stuff as much as I want. And as long as the interface is the same, nobody will notice. It'll still compile, it'll still work. Okay, that's our thesis statement. Okay, does that make sense? Interface. Separation of concerns. That's why we go through all this rigmarole of getters and setters and all that stuff. It lets you maintain your invariants. If you comment out stuff, the invariant doesn't hold anymore. Yeah, that's true. So I'll comment out the class invariant. There you go. Right. Yeah, there's nothing in the language itself that guarantees the class invariant. There are tools that you can do to say this must always be true, and then the tools will kind of prove that your code is correct, or it'll watch your code at runtime and always guarantee that radius squared is equal to radius times radius. Like there are tools that do that, but the comments are just comments, and so they have no legal weight. If you break them, you break them. If you delete the invariant, you no longer have to follow it. Yeah. Now you're thinking like a programmer. Muted or just me? Can you guys hear me? Let me check my audio settings. Settings. Audio. Yeah, it's still recording. Hello? Hello? Okay. All right, so your next homework assignment, because I want to really hammer this point, because really this class is about class. This class is about the classes, right? And you have to really understand this concept. And so I'm going to give you another homework assignment that is similar to the fraction assignment, but not fractions, because you've done that twice now, and I don't want to kill you guys on it. And it will be a partnered assignment. And what you're going to do is you're going to have one partner. There's going to be two classes. Okay, for this assignment, you guys are going to be doing imaginary numbers. Do you guys know imaginary numbers? My daughter hated the notion that there were imaginary numbers. I mean, to be fair, she cried the first time she found out about negative numbers. Yeah. Like, she didn't think it was possible for you to have negative apples in your hand, right? Like, it doesn't make any sense. And then when I told her, all right, let me tell you about imaginary numbers, like, her poor little brain melted. Okay, so this is going to be a partner assignment, but before you guys dig into it, and if any of you guys have partners you want to work with, just message me and I will set you guys to be partners with each other. Otherwise, I'm going to randomly assign them. So let's go over this. So while I'm talking, just message me if you have a partner. Okay, so there are two classes in this one. In the last one, there was one class. There was the fraction class, which had a numerator and a denominator, and you had to maintain a class invariant. For this one, there are two classes, because we're going to be doing complex numbers. And so a complex number, if you guys remember Algebra 2, it's a number like this, 5 plus 3i, or something like that. So there's actually two different parts to a complex number. There's the real part, which is, an integer, I think. I don't think we're using doubles for this one. And there's the imaginary part, which is a coefficient times I. So it's an integer times I. And so if it sounds like the fraction class, you're right. Rather than a numerator and a denominator, there is a real part and an imaginary part. Okay. Be careful though. The word imaginary is actually used in the standard library, so you can't use it. So you might see. Yeah, I used capital I for imaginary, not lowercase I. Yeah, or I call it imagine instead of imaginary, because if you call it imaginary, see how it turns green? You guys see that? Anytime a word turns green, that means that Vim recognizes that as a keyword or something. And so don't try and do that. I think complex might, yeah. So complex, don't make a variable called complex. Don't make a variable called imaginary. I wonder if real, real, you can do real. No, I have a real there. Yeah, okay. Imagine. I just called it imagine. Okay. Sound stopped again. Imagine dragons. You don't like negative apples, right? Let me tell you about debt. Yeah, you owe me 4 apples. Hello. Okay, so you guys are gonna have partners, and one partner is gonna do complex, and one partner is gonna do imaginary. Okay, so you're gonna get this experience of like, wait, somebody else is using my code. Okay, so you're gonna have a client and customer, relationship, or a developer client relationship, right? So one person's gonna be writing the imaginary class, the other person's gonna be using the imaginary class to do the complex numbers, because the complex number is got an imaginary in it. A complex class has that's the name, has a imaginary in it. It's a has a relationship. A complex number has a int and it has a imaginary. And you're going to implement, did you guys have any trouble with the operators last time? I tried to make the fractionation one pretty straightforward, right? Like, I give you guys like a working operator plus, right? And so this takes in a the other fraction that's being added to it. So if you add 2/7 and 3/2, we are 2/7. This, my num is 2 in this case. And then the other guy on the right-hand side is 3 seconds. This is working code, right? It finds a common denominator, adds the numerators together, blah, 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 blah. All you had to do to get operator minus to work is to copy and paste this code and change the plus to a minus, and you would have gotten a point. Like, this is a skill that I really want you guys to get good at, except for the two of you that cheated and literally copied everybody's code. Don't do that. You need to get good at copying and pasting code, and then modifying, right? This is how computer scientists learn, right? So rather than making you write one of these things from scratch, all you had to do is copy and paste this and change that one letter, that one character right there, that plus. That's it, and that's a free point. And then for multiply, rather than doing a common denominator, multiply is even easier. The numerator is equal to the product of the two numerators, and the denominator is equal to the product of the two denominators. That's it. It's even simpler. You don't even have to find a common denominator. And division is the same as multiply, except upside down. So that was like 4 free points. It's like literally everybody should have gotten at least 4 points on this. And then the input and output was like another couple points. And so you should have had at least a 6 on this, honestly, if you put any time in it at all. All you needed to do is change this so that it's like, that's literally the answer right there that I gave to you guys. So, except instead of cout, you would use outs to be more proper. It would actually work with cout, but that's bad code, because you want it to work with any sort of output stream, like a file or something like that. Okay. Whoever designed LN1 Vim should get fired. It's the font. Yeah. Do you message you this or chat? Message me on Discord. PM me. What does imaginary mean in language? So imaginary is the square root of -1. And so there's a whole thing in math of things you can do with the square root of -1. Because if you think about it, the square root of -1 doesn't have an answer, right? In terms of regular math. The square root of 25 is plus and minus 5, but the square root of a negative number doesn't exist in the real world, because anytime you square something, you get a positive or a 0. Okay. So refer back to your fraction class if you want to see how operators work. This one thing you might notice is that this assignment is having you guys do classes a little bit more properly. So there's this complex class, which one of you guys is going to be doing. And all it has is in the class. See, before what we had was we had all the functions inside of the class itself, which is a way that some people do it. It's not bad per se, but usually we do it this way to speed up compilation time. And we'll talk more about how compilation works next time. But you don't have to modify this file at all. So complex.h, you don't have to modify. Done. That's all the stuff you have to do, though. And then imaginary.h, you don't have to modify that either. Okay. And so the imaginary person has to implement these operators, plus, minus, times. There's 2 different times, right? Because you multiply a real times an imaginary, or you can multiply an imaginary times an imaginary. And so if you multiply 5i times 5i, what do you get? You guys remember your imaginary numbers? If you multiply 5i times 5i, what do you get? What does C-error do? C-error is like cout, except the input tester does not pay any attention to it. So if you have any debugging lines that you don't want to get picked up by the autograder, just put them in C-error. So 5i times 5i is -25. -25. There was an alternate reality game involving a channel that uploaded high-quality song rips. Part of the puzzle was realizing the lowercase L in the username was an uppercase I. That's hilarious. So outs, in that case there, it's an O stream. And so it's a placeholder for any kind of output stream. The most common output stream you guys deal with is cout, but it would also work with C-error. It would also work with a file. It would also work with a network stream from the Boost library that does writing to the network. So you could use that to cout an imaginary number to the network if you want. You can write it to a string stream, which is a string that works like a stream. So you can output things to a string to build up a big string. String. Yeah. So OStream is a class that works for a lot of different things. And if your code was just couting the things, it would probably pass the test cases, but it's also wrong. It's also wrong. Don't. Yeah. Okay. So, yeah. And so one person's going to do imaginary, one person's going to do complex. And the complex person relies on the imaginary person, or your code's not going to work. So I would actually recommend just working on it together, honestly. I just pull up share your screen on Discord with each other. Do you guys know how to do that? You can, if you right click on somebody, you can video chat them and then share your screen, and just looking at it together. And the way that pair programming really should be done. There's actually I found a good web page on this. Let's see here. These are all different tools for doing pair programming and stuff like that. I'll post them on the Discord channel. But basically what you can do is you can just share your screen, kind of like what I'm doing now. And then what I would recommend is that one person's the typer, and the other person is actually telling them what code to type. This is a very powerful way of doing pair programming. So one person is an intelligent typer. They're just a keyboardist. They don't come up with a design or any of that stuff. The other person's going to be like, okay, make a for loop that 10 times will do this. And then the person will be like, 4 int equals 0 is equals. Okay, now do this. And so, and then every 15 to 30 minutes, you switch. So set a timer, and then you switch who's typing. Okay? That's one way of doing it. If you had to do that, though, you would need to share login credentials, which you may or may not want to do, depends on how much you trust them. There are different tools down here. There's a lot of tools here. And I don't know. I just saw this yesterday, so I haven't gone through them yet. I know Cloud9 has been used before. Cloud9 allows you to share a code. It's like Google Docs. We can type at the same time. Covim, unfortunately named in the world of COVID. Covim allows you to share a Vim session on the server. So you might want to look into that as well. Okay, so pair programming is actually really good for you, and it will help you learn and get better and stuff like that. So where is the stuff you're actually going to be implementing? Well, so if you're going to be doing imaginary.h, this is the class definition. The class declaration is in imaginary.cc. And so what you'll see is that the constructor is not named just imaginary, it's imaginary : imaginary. And so what the : means is that's called the scope resolution operator. Can you pin that link? Yeah, I can pin that link. It is now pinned. What the : means is it says we are talking about the imaginary function inside of the imaginary class. We are talking about the operator plus operator inside of the imaginary class. That's what imaginary : means. It's specifying to C++. We're editing that function. Okay. So even though we are outside of the class, we're not outside of the class. We're actually inside of the class. That's what this does. This is saying we are inside of the imaginary class right now. That's what that means. So I would start off with you and your partner doing the imaginary class, because the complex class won't work until the imaginary class is done, right? So you have to write a getter. So this should probably be like return coef. Just giving that one to you guys. Here's a working operator plus. So same thing. Copy and paste the code to make operator minus, right? In fact, I think I did that for you already. Right? So yeah, just look at how the code works for one thing, and then change it to another thing. Operator times you need to do. Right now it's just returning 0. Right now operator times is returning 0. Obviously that's wrong, right? These two things are done for you. You don't have to do them. Comparison operator right now is returning true for everything. So let me go ahead and create groups here, guys, on Canvas. two students group. And you can self-sign up? No. No. Group. Yeah. Go onto Canvas and find your buddy and message him. If you guys have messaged me, I'm gonna pause the stream right now, and I will start fixing those groups. Okay. So otherwise, if you haven't messaged anyone, just go ahead and message them now.